In physics, we're often studying the motion of objects, and the most simplest form of motion in physics is considered one-dimensional motion. In 1D motion, we're looking at an object that is traveling along a straight line path. And that object can only move in two directions along that path. So when we're thinking 1D motion, we start to consider direction. So when we're talking about direction, in 1D motion, those directions can be moving to the right or to the left. What you might call right, we might call it east, or we might call it west. All right, an object can be moving up or down, which we might say is north or south. And in physics, we use math as our language. So when we're talking about direction, this is where we look at the sign of a number. So all of these, we're talking about right, east, up, north, all of these we would consider the positive direction. And if I'm going left, I'm going west, I'm going down, I'm going south, these would be the negative direction. Now keep in mind, right, the direction, right, left, east, west, these would be along the x direction. This is, again, we're talking math language. So things that move horizontally, we would define it as the x direction. However, some objects move up and down. A ball falling would be something that is moving vertically, and we would assign y as our variable. This would be our vertical motion. So we can use x and y as the directions, just like we do in math class. And things that are moving upwards or right, we would assign a positive value to those numbers to indicate the direction of the motion. So if an object's moving in 1D motion, we need to be able to identify where that object is located. And we call where an object is located, we call that the position of an object. Position is where an object is located, or an object's location. We need to be able to have a reference point to measure from, and we need to be able to identify where it's located from that reference point. So if you think, again, on a highway, you have mile markers as a basic reference point. If you're measuring on a meter stick, the different marks on that meter stick might be different positions you could have. And again, if we're talking about the horizontal direction, we might label position with a variable. That variable for position is often x. X represents position. And as we just saw above, this is typically along a horizontal motion. And if an object is moving horizontally, it can actually be changing its position. So this is where we get labels on this variable of x, and we call these labels subscripts. A subscript, again, is just a label on a variable. And you'll start to see a lot of these little subscripts in physics, and they often can confuse students when we're just getting started. But just understand that if I'm describing where something is located along a horizontal path, each position would be a position on that x-axis, if you will. They're all x values, but they're not all the same position. So I might want to call it the first position. I might put a little 1 there as a subscript. And then later it moves, and now it's at position 2. And then position 3. So you'll see 1, 2, and 3 as ways to label with a subscript. You might decide to call them by letters, A, B, C. There's a couple other ones we typically will see. The first position we are located at, we often call the initial position. So we put a little I there. So I, that would be the initial position. Now, depending on how you're learning physics, you might have somebody, instead of calling it initial position, they might call it position at time 0, or as they do in positive physics, you'll put x sub 0 or x naught is one of the terms. And at some later point, or at the end of the problem, when we're typically evaluating something about the problem, we would call that position the final position. So you might put an F there for final position. Again, these subscripts are really just labels on these variables. They're all locations along the horizontal axis, and we label in such a way that we can track where this object is throughout the problem. Once again, it's not always X. If we're talking about vertical motion, right, these are positions along the y-axis. So we use y to define variables of objects moving along a vertical path. So let's look at a number line. Again, if I'm thinking 1D motion, I'm thinking of motion along a number line. So if I just draw from math class here, I'm going to draw a little number line. We can define some positions. Again, it's really important to have a reference frame. So here's my number line. I'm going to define to the right as my positive direction, just like we do in math class. Now, again, as long as I'm consistent, it really doesn't matter which way I define positive and negative, but because we learn it in math as our language, that right is positive, we're going to be consistent here and typically draw things that way. At some point along this number line, there's got to be an origin or some reference point. So I'm going to put a point on here. I'm going to call this a location of 0 meters. In this case, I'm measuring positions in meters. And anything to the right, I'm going to assign a positive value. So positive 1 meter would be to the right of that reference point. And that means if I go left, I'm actually dealing with a negative position. And this is where the math and the physics start to come together, because as I move further left, I'm just moving more in the negative direction. And as we learn to handle math values, negative numbers, we can handle physics problems with negative numbers all the same. So it's just important to understand that now negative is not just some math concept, it's really just defining direction. So if I tell you an object is located at negative 2 meters, all that means it is 2 meters to the left of my origin. And in a physics problem, the origin might be a specific town or a starting position that this object is located at. And we often get to choose where we put the origin, and we may want to choose it such a way that we don't actually deal with negative numbers. But it's important to understand and feel comfortable that when we see negative in physics, that just means direction, left. And numbers without a sign are typically assumed to be positive, and we would assign that to the right, or up or down, depending on how you set it up. So this is just a quick introduction to 1D motion. Motion along a straight line path. We can typically think of that as along a number line. It has direction. It only has 2 directions depending on its motion. And we can label positions along its motion with variables of x for horizontal motion and y for vertical motion.